balance the combustion of butane? Not a lot in this question, so we don't have an equation to balance yet. We don't even know what butane is yet, but we actually do. It's in a slide somewhere. Butane has 4 carbons and 10 hydrogens. So we know at least what's combusting. Then the other important thing to understand is that in a combustion reaction, you're always going to have something combusting by mixing with oxygen, which is diatomic in its elemental state. And the products are always going to be carbon dioxide and water. So because we understand what a combustion is, we can write all the compounds that are going to be in our chemical equation. Now we have to give stoichiometric coefficients to each compound, and do that in such a way that no atoms are created or destroyed during this reaction. So if there are 4 carbons on the left side, there must be 4 carbons on the right side. The only place where carbon appears on the right side, or the product side, is in carbon dioxide, so there must be 4 carbon dioxides created. We also need to balance the oxygens and the hydrogens. And I'm going to balance hydrogen first because I'm saving oxygen to do last. If there's a pure elemental compound, it's the one you want to do last. Because if we try to fix oxygen by changing the number of waters, we're going to change the number of oxygens, but we're also going to change the number of hydrogens. And then we'll mess up our hydrogens and we'll have to go back and change hydrogens somewhere else. Since I'm leaving oxygen for last, I will fix hydrogen out by changing the coefficient here. I'm not sure what it's going to be yet. Let's call it x. But I know that on the right side, on the product side, there must be 10 hydrogens because there are 10 on the left. So x isn't going to be 10 because that would mean there were 10 waters. Each water has 2 hydrogens. So what we do know is true is that x number of waters times 2 hydrogens per water equals 10 hydrogens. So our coefficient for water must then be 5. While we've been fixing our carbons and hydrogens, we have been accumulating a lot of oxygens. So in the carbon dioxide, we have 4 times 2 oxygens. And we also have 5 waters with 1 oxygen per water, so another 5 from the waters, and that's going to be a total of 13 oxygens on the right side. Oh boy, we need 13 on the left side. So let's call our coefficient here, let's make it y. So we know that YO2s times 2 O's per O2 is 13. And here y would be 6.5. If you don't like having a half in your answer, you can just multiply every coefficient by 2. So implied 1 here becomes 2 butanes. 6.5 oxygens times 2 is 13. 4 times 2 is 8 carbon dioxides and 10 waters.
Made with Doodlecast Pro.